So let's jump into our area questions for today. I just want to recap some of the things that we spoke about on Wednesday, and especially for those of you that are new, this might be quite helpful. So just to remind ourselves of how we calculate the area of different shapes, remember the area is the amount of space that a shape takes up. So as I'm doing this, it's going to be so much easier if I just type it. And we're talking about area in a two-dimensional sense. So area, I'll get there in the end. The amount of space a shape takes up. Oh, it's gone really badly. Right. Now, when we talk about that, we're not talking about the outside length, which we know is the perimeter. We're talking about sort of if we were to color in the shape that we're working with. How much am I coloring in? So again, amount of space. Now, there are different formulas that we use for different shapes that we're working with. If we think back to a square, now we can use A to represent area. When we start talking about 3D shapes, we can use surface area, but for now we're just talking about 2D shapes, so we're going to use A. The area of a square, we can use the similar formula to the area of a rectangle, but if all of the square's lengths are S units, then we can find the area by saying S times S. You can shorten this to S squared, but basically what you want to do is you want to multiply two side lengths together. So that's how we work out the area of a square. The area of a rectangle, this is the one most of us remember, is length times breadth. You don't have to write your letters like that. You can just write an L and a B. You can also say length times width. Really doesn't matter. It means exactly the same thing. Remember, your length is your longer side, your breadth or your width, the shorter side of the rectangle. Right, if we want to find the area of a triangle, this is a slightly more complex formula. It is half times the base length times the height of the triangle. Now, what we need to remember is that those sides in a triangle are very important to be able to identify. Your base length, your base length, it can really be inside of your triangle, but it's generally the bottom side of your triangle. So this red side down at the bottom. And the height of your triangle is always perpendicular to that base. So this height of our triangle is going to be the height from the sort of highest or topmost point down perpendicular to the base, so at a right angle to the base. And that is our height. Sometimes we need to work that out using Pythagoras. Sometimes we're given it, but that is essentially the height of our triangle. And then finally, we have our circle. Now remember, whenever we're talking about circles, we're generally going to use pi somewhere. And the area of a circle is pi r squared. You can also write it as pi times r squared, or if you want to expand it even more, pi times r times r. Now, some of you in school would have been told to use pi or to write pi as a specific number. So some of you might have been told to write pi as 3,14 or 3,142. If you've been told to use pi as one of those two values, it is obviously absolutely fine that you do that. Otherwise, you're using the pi button on your calculator, which is just above the times 10 to the power x. Or it might be somewhere else. It depends on the calculator that you have. So if you've been told to use pi as 3,14 or 3,142, that's what you do. Otherwise, you just use the pi button on your calculator. So guys, these four formulas are sort of the four foundational formulas that you need to know for measurement. These formulas you will use right up until matric. And these formulas we also expect you to know. So we won't necessarily give you these formulas, we expect you to know them. And so they are very, very important to put into practice and very important to work with. So what I'm going to do is I'm going to just wait on this screen, for lack of a better word, for a couple seconds so that you can take a screenshot if you would like. And we'll then carry on. Future, the formula for rectangles is this one that I've put here next to our rectangle shape. So it's length times breadth. Okay, I'm just giving everyone a chance to screenshot. And then we're going to have a look at some examples of using these formulas. Okay, so let's have a look at some examples. Now, guys, remember we're stepping up a little bit here. We have already done some basic area examples. And so if you are new, that's absolutely fine. You can go and find the video on Watobe's website. But now we actually want to look at slightly more complex questions and see if we can go and work out areas or use our area formulas here. So the first example that we have here says to me that the area of a square is 42,25 centimeters squared. Determine the length of the sides of the square. Now, what I often find quite useful is to draw a picture of what I'm working with, just so that I can sort of visualize what shape it is I have. So here's my square, and I have been given information about the area. Now, remember, the area is all of the space that the shape takes up. So if I were to color in my square, that would be its area. Oops, I don't know what happened there. So if we talk about the area of the square, we are told that it's 42,25 centimeters squared. Now, another important piece of information about a square that we know is the fact that all four sides are equal. So if I sort of come up with a variable to represent them, they all have to be the same. So they would all be x centimeters long. They would all be identical because it is a square. And so what that means is we can go back to our formula for a square, or the area of a square rather. So we know that the area of a square is equal to side times side. And we have been given the area. So we have been given that the area is 42,25. And we have said that we're going to say each of these sides is x. So we've got x times x. And so now this is an equation that we can go and solve, because we know how to solve for x because we've done equations before. So we know that x times x is x squared. So we've got 42,25 is equal to x squared. And we know, because we've spoken about things like Pythagoras and we've spoken about equations where you've got squares, if we want an x alone that's attached to a square, we need to square root, because the square root cancels out the square. But I have to do that on both sides of my equation in order to keep my equation balanced. And so what this is saying to me is that the square root of 42,25 is going to give me the value of x. So it's going to give me the side length. Now, if I square root 42,25, I get an answer of 6,5 centimeters. And so what this answer is saying to me is that each of these side lengths of my square, so each of these four sides, is 6,5 centimeters. Now, importantly, we're looking at a length. So we're not looking at an area. So there's no squared to our answer. It's just centimeters. And we can go and check this, because now I've established what my side lengths are. And so if I now know that this is 6.5, 6.5, and so on, if I want to double check if my answer is correct, I can substitute it back into my area formula. So now if I go and say, well, let's double check and say 6.5 times 6.5, or 6.5 squared, doesn't really matter. If I now go and work out the area with that length, I get 42,25 centimeters squared. And because the area that I'm getting is the same area as what was given to me, I know that the length I've worked out is correct. Okay, so this is an example of using my formula to go and work out an unknown length in one of my shapes. Okay, so take a screenshot if you'd like, and then can I just get a thumbs up or thumbs down in the chat how we feel about these sorts of questions? Do we find it okay? Was the explanation fine? Do we want to try another one before we move on? So thumbs up if you feel fine, thumbs down if you'd like another one. You can react as well if you'd like. Okay, so for the most part, there's some thumbs up, which is awesome. Very nice, guys. Right, we're a bit of a mixed bag here. So some thumbs up, some let's try another one. So what I'm going to do is I'm going to give you guys another one to try by yourself. So for those of you that are feeling good about this question, that's awesome. You can now try one by yourself. For those of you that aren't, give it a go, but we will go through it. So let's have a look at, maybe I should draw an actual proper shape. So we've got a square, panic. Right, so the square has an area of 52,56 centimeters squared. Whoops. Just fix that. Determine the length of one side. Okay, so give this one a go. I've told you that this is a square and it has an area of 52,56 centimeters. I would like you to tell me what the side length of the square is. Right, please remember at this current point in time, our topic that we are doing is area and perimeter. Any other topic that you would like help on, there are videos on Watobe's website, or as Yolanda has said, you are welcome to join class about 5 minutes early, and I'm more than happy to answer any questions that you have. Guys, just for your answer, please round to 2 decimal places. I'll just put it there in the instructions just in case. And then if you have an answer, you are welcome to put it in the chat, or you can raise your hand so that we can hear how we can solve this problem. Remember, guys, I'm looking for a length, so my units will just be in centimeters. Bontle, very nice. I hope we're all giving it a try. Seeing some good answers come through. Remember the units, it's a length, so we need to have units there. If anyone's feeling up to raising their hand to explain it to us, that would be awesome. If not, I'm going to give everyone another minute or two and then I'll go through it. Okay, Bontle, do you want to explain it to us?
Yes, ma'am.
Okay, awesome.
Ma'am, since you gave us a square and a square has 4 sides, I used your previous method and I said 52,56 centimeters squared is equals to x times x.
Good.
Then, ma'am, underneath I said 52,56 centimeters squared is equals to x squared.
Good.
X times x squared. Then, ma'am, then I squared both of the. If I squared the x squared, then I have to square the 52,56. Then
Okay,
that
so
gave me
square root, yeah.
Then 52,56 squared gave me 7,24,98275, but I rounded off to the next 2 decimals.
Good.
That's 7,24.
Okay, perfect. So I'm just going to write a few decimals here so we can chat about rounding. Excellent, Bontle, well done.
Thank you, ma'am.
Okay, so guys, just a couple things. We set it up very much the same as Bontle said as the last one because it's a very similar question. It's just different numbers. As Bontle said, we don't want that x squared. We want an x, which means that we need to square root both sides. And if you square root 52,56, you get that whole long decimal. So 7,2498, and there's a whole bunch more. Now, if I'm telling you, as I did in the instruction, to round off to 2 decimal places, what we want to do is we want to look at the third decimal, which is a 9, and we want to see what effect it has on the second decimal. Now, if that third decimal is 5 or more, it is going to increase the second decimal. So this rounded off to 2 decimal places is 7,25. And then importantly, it is in centimeters because those were the units I was working in. And so each of these side lengths of my square is 7,25 centimeters. And that will give me my area that I gave you. All right. So essentially, we can work backwards from a given area to go back to a length. Obviously, we can do this with a whole bunch of different shapes, but we obviously need to give you enough information in order to do that. I'll leave this up here for a second in case you would like to take a screenshot of this, and then we're going to have a look at another type of question that is a little bit more complex to do with area.
Y'all did well, my people. Load shedding is just shading on me, guys. So I'm in and out, but okay, I'll survive.
Okay. Right, guys. So another type of area question. Oh, so sorry. Okay. 539403334. Just remind me of your name. And then...
Hi, ma'am.
Hi.
Am I audible, ma'am?
Yes.
Okay, ma'am. My name is actually Sukwe. Ma'am, I tried doing this, but it always keeps on going on to the number. I don't know why. Okay,
so
so
your name
ma'am,
is
Sikuye.
Sikuye. Okay.
Yes, ma'am. So ma'am, my question is, because I saw that since we started this topic, you always put the x's on the variables on the right hand side. Can you also put them on the left? Because I'm used to putting them on the left because of algebra.
Absolutely. Okay. Left makes more sense to me as well. I don't know, clearly I'm having a day, but yeah.
Okay, thank you,
left or right, whatever you want.
Thank you, ma'am.
Alrighty, guys. So let us have a look now at a slightly different type of area question that involves, probably a better word for this, but like complex shapes. So shapes that aren't necessarily just a rectangle or just a square, shapes that are sort of like combined. So we can be asked to work out the area of complex shapes. And basically what this means is, and I'm just going to make my life a whole lot easier, I can ask you to work out the area of this T-looking shape. And so what I'm asking for is this whole entire area of the shape. Now, what we need to be mindful of is the fact that even though this isn't a normal rectangle or a normal square, we can try and break it up into shapes that we know how to work out the areas of. So the first thing I'm going to do is I'm just going to make sure that I have enough information to do that. Now, you guys might see something different to the way I'm going to break up the shape. You might see 3 shapes, you might see 2 shapes that you can break it up into. It really doesn't matter as long as you use the correct dimensions. So let's just make sure that we're all happy with the dimensions given. The 15 centimeters is the whole length across the shape. So I don't know, the top of the T, for lack of a better word. This 9 centimeters is from top to bottom. And this 3 centimeters is sort of like the crossbar of the T. Now, if that means that this length here is also 3 centimeters because it's a rectangular sort of shape, it means that we can work out the remaining length of, I don't know, the bottom of the T. If we have, or if we know the whole thing is 9 and we've already counted 3 centimeters, we know that this bottom bit here is then 6 centimeters, because if I add 6 plus 3, I get the 9 centimeters. Right, what I've also been told is that the, I don't know, arm of the T is 4 centimeters, and this line indicates to me that those are the same length. So this is also 4 centimeters. So in total, I've got 8 centimeters along this 15 centimeter length, which means that this bottom length is whatever remains. And so that would be 7 centimeters, because if I say 4 centimeters plus 7 centimeters plus 4 centimeters, I get the 15 centimeters. And so once I know all of my dimensions, I can start to split the shape up for myself and try and work out or work with shapes that I'm more comfortable with. Right. So again, you might see slightly different shapes to what I see, and that's absolutely fine. It really doesn't matter. So the shapes I can see here are basically 2 rectangles. I've got like a long, skinny rectangle at the top, and then a shorter little rectangle at the bottom. And so if I want to work out the area of this T shape, I can just work out the area of those 2 rectangles and then add them together. So I'm going to give you guys a second to give that a try. If and when you have an answer for me, you can put it in the chat or you can raise your hand, but I would like you to try and find the area of that T shape. So this yellow sort of shaded in bit that I've got going on there. Remember your units, it's an area, so it should be units squared. Obviously, again, guys, if you have divided your shape up into slightly different rectangles, that's okay. As long as you're using the correct dimensions, no problem at all. So remember, we want the area of the whole T shape, so all of that yellow sort of shaded bit. Okay, so guys, remember, based on what we've sort of drawn here, we've got one long skinny rectangle, and we've got a slightly stockier rectangle that we need to work out the area for. And so this top rectangle was 15 centimeters by 3 centimeters, and this bottom rectangle was 7 centimeters by 6 centimeters. And so if we work out the area of those 2 shapes and add them together, we can go and work out the total area. So just bear that in mind when doing your answers. I'm seeing a lot of 39s. I'm not too sure where we're getting that, but just be careful. Make sure you are working with the correct dimensions and the correct shapes. I'm going to give everyone another minute or so. Okay, I'm seeing 1 or 2 nice answers come through. Very nicely done. I'm getting a very wide range of answers here. So I'm just going to go through this just so we can all be very clear on how we find this area. Okay, so guys, like I said, we've got 2 rectangles here that we want to work out the areas of. I'm just going to make this slightly smaller so I've got some space. Now, if I work with this sort of longer rectangle, we know that the area is equal to length times breadth. And so what we need to do is we need to say 15 times 13. Now 15 times 13 times 3. 15 times 3 is 45. Now remember, this is an area, so it's 45 centimeters squared. So that 45 centimeters squared is talking about the area of the top sort of crossbar T-bit of the shape. So that's what it's relating to. We then want to work out the area of the bottom rectangle. And so again, we'll use the same formula, length times breadth, which is 7 times 6 or 6 times 7, doesn't really matter. But that gives us 42 centimeters squared. Again, it's an area, so it's units squared. And what that's doing is, again, it's this bottom sort of bottom of the T. And so we're talking about this area over here. Now, because we want the total area, what we need to do is we need to add these 2 together. And so the total area of the shape that we are working with is 45 centimeters squared plus 42 centimeters squared. And that gives us 87 centimeters squared. So the total area of that shape is 87 centimeters squared. And I could do that because I could break my complex shape up into shapes that I am more comfortable with in terms of being able to work out their areas or use appropriate formulas that I have. So this was quite a tricky one because we did have to be able to break up our shape or break it down into shapes that we're more comfortable with. But just remember that once you found all of the component areas, we just add them together in order to get our final total area. So I will leave that up in case anyone would like to take a screenshot. Bontle, I see your hand up. Do you have a question? Bontle?
But you'll have to unmute on your side, unless if it's my network that I can't hear anyone.
I'm also not getting anything. Okay, no problem. Tandor, do you have a question for us?
Yes, ma'am. Hello.
Hi.
So, ma'am, I wanted to know, where did you get the 7 centimeters from, and where did you get the 6 centimeters from?
Okay, perfect. So the 7 centimeters, if I just take all of this off. The 7 centimeters I got because I already knew that I had, wait, sorry, I'm panicking. I've got the 4 centimeters along each side of my T. And so what that means is I've already got 4 centimeters from the 15 centimeters on either side. And so if we know that the whole width of the shape has to be 15, and I've already got 4 centimeters on either side, that's already 8 centimeters that I've got, which means that the missing sort of width at the bottom is then 7 centimeters, because 7 plus 8 gives me the 15 centimeters in total. And then the same thing happens for the 6 centimeters. I've already got the 3 centimeters along sort of the top bit of the T. And if the whole thing is 9 centimeters, what I'm then missing is 6 centimeters.
Oh, because on the 7 centimeters, I thought you just added the 3 centimeters and the 4.
No, so I just worked it out based on the total length that I had from the top of my T shape.
And the 6 centimeters, you got it from, what do you call it? Did you get it from dividing,
So the 6 centimeters I got because I've already got 3 centimeters up here. And if this whole thing must be equal to 9, what I'm then missing is 6 centimeters to make up the 9.
Okay. Thank you.
Good. Alrighty, guys. So just bear in mind that there's other ways that you could break this up. Bear in mind that sometimes we do need to do a little bit of work beforehand to work out dimensions that we're missing. You could have broken it up into 2 slightly smaller rectangles and then 1 big rectangle. It really doesn't matter as long as you are breaking it up into shapes that you're comfortable working with in terms of working out the area, you'll get the right answer. Alrighty, so I'm hoping everyone's taken their screenshot. I'll wait here for like 10 more seconds and then I'm going to scroll down to our brain break. We're going to do it the same as normal. First person to get the answer, pop it in the chat, and then we'll hear from you how you did it. Oops. All right, so here's our brain break. We're going to mix it up as of Wednesday because I know we've done a lot of these, but here's our brain break for the day. So like I say, first person to get it, pop it in the chat, and then we'll hear from you how you got your answer. Look carefully at the pictures. Some of them have 2, some of them have 1. Look carefully at the operation.
Let's go. Let's see who's the winner of our brain break. Brian the Brain, my peeps. Let's go. Let's go, my people. Let's go, my peeps. It's not 18. Remember, we are looking for the final answer. So if you're giving me 18, you're giving the clues of what other people need to find. So 18 is not a final answer. I'm looking at the final answer where there's a question mark. If you can tell me that answer, you're the winner of today's quiz. Let's go, my peeps. We can do this. Just calculate nicely and realize that there will be others are 2, others are 1 in one place. There's multiplication, there's addition. Let's go. We can do this, my people. I want to see who's going to get it first. My money's on Lufuno. Lufuno, you are very concentrated. Let's go, Lufuno. Let's go. And that's it. Atini got it. Well done, Atini. Well done. That was so fast. Atini, would you like to raise your hand so you can explain to the class how you got your final answer? Well done. Well done. Atini was the first one, and then Lovu the second. Yes, Atini, we are waiting for you so you can explain to the class, and then we can move on with maths. That's exciting, Atini. You win. Today's quiz is Atini's day, my pips. There we go. Atini, please explain to us step by step.
Afternoon, ma'am.
Hi.
Okay, for the first one, I calculated 9 times 9, 9 times 2, plus 9 times 2, plus 9 times 2, which equals 18, and then plus times 3, or you could just 3 times equals 54. Then for the last one, the second one, since it was 9, I said 25 take away 9 equals 16. Then I said 4 times 4 equals 16.
Nice.
And then for the third one, since the reindeer is 4, I said 4 times what equals 4 times 6 equals 24, plus 6 equals 30.
Good.
And then for the last one, since I know that the snowflake is 9 and the reindeer is 8, so the reindeer, 2 reindeers equals 8, plus 2 Christmas trees is 12. I said 9 times 12 plus 8 equals 116.
Excellent. Well done. So guys, very important there, as Atini said, we have the multiplication that has to happen first. Multiplication must come before addition. And so that gives us 108 plus 8 gave us our final answer of 116. Excellent. Well done. Very
Thank you,
quick
ma'am.
as well. And guys, importantly, it was quite interesting to hear how Atini actually did it, because like, remember that each of these snowflakes actually represents 9. And so that 9 times 2 step, I've never thought of it like that, but that's awesome. And so again, we could say, because we're adding the same 3 things, we're actually just multiplying the same value. So 18 by 3. So however you're choosing to think about it is absolutely fine, as long as mathematically it's all sound. There's really a huge number of ways that we can sort of think about these sorts of questions. Very nicely done. Well done. And I know that there were quite a few other people who got 116. So well done, everyone. I'll leave it up there for a second or two if you do want a screenshot. Otherwise, we're going to carry on with our area questions.
Yippee, Bongeka, is that a question? And Tando also.
Okay, oh, there we go.
Sorry, ma'am. Hello, ma'am.
Hi.
Yes, ma'am. Can you please go back to the first one?
The first example?
Yes, ma'am.
Okay, I will go back there now. Alrighty, so just for those who did want the first 2 examples, there you go. Do take a screenshot, and then we're going to have a look at our next one. Alrighty, so if we have a look at our next question here, we've been asked to find the area of the triangle below. Now, very importantly, the area, or rather the triangle that we are referring to, is the triangle MNR. So this blue triangle over here. What we need to remember is that if we just quickly jump back up to the area of our triangle, we always need a base length and then a perpendicular height, or a height from the top point of our triangle to the base. Now, sometimes what happens is my triangle is sort of in a different orientation that makes it a little bit harder to see, but they've helped us out here a bit by giving us a right angle and telling me that the distance from, and technically this is in line with my base, the distance from my base to the top point, or the highest point of my triangle, is 8 centimeters. What they haven't given me is the base length of my triangle. So you almost need to imagine this triangle flip the other way around. And I don't even want to attempt to draw that because it would be quite shocking. Let's try. You almost need to imagine the triangle sitting something like this, with this whole length over here being 14 centimeters, our perpendicular height being 8 centimeters, and this sort of slanted distance over here being 10 centimeters. That's essentially what information we've been given. Now that's all well and good, but the problem is, like I say, I don't have my base length. I don't know what the length of this base side is, and I therefore need to go and work it out. Now, this will often be the case, and often what we will need to do is we will need to use Pythagoras. What we see here is that because of that right angle, I actually have a right angle triangle. That wasn't a great right angle triangle. I'm going to try again. We have a right angle triangle, didn't get better. 3rd time's a charm, right? A right angle triangle. And so if I work out this length over here, we can call it X or we can call it NP. I can subtract that from 14, and I will then be left with whatever my base length is. And so essentially, by using Pythagoras, I'm eventually able to get to my base length. So if we go and use Pythagoras to go and work out this English, missing length. We need to obviously remember what Pythagoras is. Pythagoras says to me that the hypotenuse squared is equal to the sum of the square of my two other sides. Remember that the hypotenuse is always opposite the right angle. So this would be 10 squared is equal to 8 squared plus x squared. We'll get there in the end. And so this therefore means that 10 squared minus 8 squared will give me x squared. Now remember that is still x squared, so we are going to have to do something to that. But 10 squared minus 8 squared is 36. So 36 is equal to x squared. I want x alone, so that means I'm going to have to square root both sides. And so therefore that x is equal to 6 centimeters. So now I know that this little length is 6 centimeters, and I can work out the rest of my length because I know the total length is 14. So if I now say 14 centimeters minus 6 centimeters, I get that this base length is 8 centimeters. And now that's great because I've got enough information to go and try and work out the area of my triangle. Because remember, the area of my triangle is equal to half times the base times the height. Remember, your base length is now this 8 centimeters we found, and the height is the 8 centimeters that was the perpendicular height that we were given. So I want you guys to just spend 10 seconds to go try to work out the area of this triangle for me. We've done half the work. We just now need to use our formula to work out what the area is. Remember, it is an area, so it's going to be units squared. You can put
Got this, my babes. Let's go.
If you want to put your answer in the chat, you can. Or you're welcome to raise your hand to explain it for us. Lorraine, would you like to explain it for us?
Hi, ma'am.
Hi.
I just wanted to ask, is 10 cm the height?
Sorry, can you say that again?
Is the 10 centimeters the height?
No, the height is this 8 centimeters down the side here, this PR length.
Okay, madam, thank you.
Okay, guys, so that's a very important question. Do remember that your height is always from your base length or your base side to the tallest or to the top point of your triangle. And so that 8 centimeters is the height of my triangle. And we can sort of see that here where we've redrawn the triangle. That total height is 8 centimeters. Right, let's have a look. So if we now substitute in the information that we know the base length is 8 centimeters, and we know the height is also 8 centimeters. And so what you have there is a half times 8 times 8, which gives you 32 centimeters squared. So the area of this blue triangle is 32 centimeters squared. Was a tricky one because there was some information that I was missing. And like I say, often we like to leave out information that you then have to go and work out before finding the area. And this is an example, especially in triangles, of us doing that because often we'll expect you to use Pythagoras in order to work out some missing information. Okay, so take your screenshots and then we're going to have a look at one more.
You guys are doing really, really well, my babes. Take screenshots. Make sure you understand and ask questions. Thunder.
Sandra, are you there?
Yes, ma'am. I wanted to find out for where we have to find the area. I wanted to find out why did we have to use 8 on the base instead of 6?
Okay, so remember the triangle that I'm working out the area of is this triangle over here. And so
Yes,
the
ma'am.
base length that we had is the 8 centimeters. The 6 centimeters I just used to find 8 because the 6 centimeters is essentially this dotted bit over here. So I need to take away the 6 centimeters from the 14 in order to get what is left over here.
Oh, okay.
Okay, so guys, just to re-explain that, also hopefully a little bit neater than whatever that nonsense was. We used Pythagoras to work out that this dotted length NP was 6 centimeters. Now, I don't care about that length. That isn't important to me because the triangle I care about is this blue triangle over here. That's the area I'm wanting to find. But having that 6 centimeters allows me to work out this length of MN, because if I know that the whole thing is 14, 14 minus 6 centimeters gives me 8 centimeters. And so this length of MN, which is my base, is then 8 centimeters. I then know the height is from the base to the sort of tallest point, which is 8 centimeters. They gave that to me. And so then in substituting into my formula, I had both the base and the height as 8 centimeters. Okay, now this was quite a tricky one, so don't stress too much, but it is an important one because, like I said, these are often the types of ones that we will ask. We're going to do more of these in Wednesday's lesson, so that's why I'm saying don't stress. But it is important to be able to sort of do calculations beforehand in order to get us to the answer that we're looking to find. Alrighty, I'm not going to do another one just because I think we'll run out of time.